So now we'll be discussing managed JupyterHub services. So what is a managed JupyterHub? Well, it's basically a JupyterHub. And so, we've talked a little bit about JupyterHubs already today, but just as a very quick refresher, it's a multi-user JupyterLab environment in which you provide servers to your users, and you can set them all up on the same hardware and provide them with the same software packages. And you can configure different server options for different user groups, providing access to different configurations of memory, CPU, and persistent storage or non-persistent. Like you can also have just ephemeral storage.
Sorry to interrupt again, Alex, but can you share your slides, please?
Oh, did it stop? Sorry. That.
Thank you.
Thank you. Okay. So, yeah. So as as I've already showed a similar architectural diagram here. This is just a JupyterHub, and so as I was just describing, you can set up server profiles to run a variety of to provide a variety of options of configurations, providing access to different amounts of memory, CPU, and storage. So these are typically hosted in the cloud, although they don't have to be. They could run on an HPC, on-prem. But what separates a managed JupyterHub from a JupyterHub is that somebody or some organization is helping to run it for you. So typically that involves planning a deployment ahead of time, working with the owner of the deployment to address what types of server profiles they need to meet the needs of their users without overshooting it and causing and running up large AWS bills. The infrastructure itself is managed as a service, so the owner of the deployment doesn't necessarily have to be an expert at cloud. There is the running and the maintaining of the JupyterHub is being managed, and then this usually also includes some amount of user support. So this is both support for the deployment, but then also end user support as well for the users of the JupyterHub. So all JupyterHubs, managed or not, managed by an outside provider or not, are have multiple users and so require user management. And JupyterHub is pretty open in how it allows you to set that up. So there is a built-in JupyterHub authenticator. That's what NISAR uses. There's also, you can use other services. So there's an AWS service called Cognito used for user authentication. We used that in the past. You can also use OAuth with GitHub or Google, or really any other service that works with OAuth. And you can also develop your own custom solutions. So this is really handled differently by different hubs, but they all need to do something to manage their users. Then there are software environments. So all JupyterHubs are providing their servers as a Docker image. So you've got a Docker image that includes a JupyterLab image on it, and so there are a bunch of pre-built JupyterLab images out there available. There's the Jupyter Docker Stacks repository of images. There are Pangeo Docker images, and managers of JupyterHub deployments also create their own custom images to fit the needs of their user groups. Recently, there have been updates to JupyterHub that are allowing you to bring in your own Docker image. So you don't necessarily, the image doesn't necessarily have to be provided by the JupyterHub deployment. It can be uploaded by the user when they go to start up a server. They can pass in a Docker image. So I believe this is fairly new and is being developed by 2i2c, who I'll talk about in a little bit. And then, of course, there are the content environments that we've already talked about. So these content environments can be either pre-built on a Docker image. So when a user starts up a server, they right from the first time they start it up, they have access to a pre-built software environment, or those environments can be created by the users. So that does require that they have write access to the location where they're going to create that environment. So if that's typically in situations where there's persistent storage, that's where you would save your custom built environment, and then typically the pre-built Docker, well, always the pre-built Docker images, or the pre-built conda environments are on the Docker image that's being loaded to run the server. Different JupyterHubs also handle storage differently. So some provide ephemeral storage only, and so you have access to a small storage volume, but when you shut down your server, everything that was on there is deleted, and you start fresh the next time you start your server. And then, of course, there are persistent storage options. So there are, in terms of AWS, there are EFS volumes. So these are like a typical file system that you would have on your computer. There are S3 buckets, which we've talked about, and then there are EBS volumes. The difference between the EBS volumes and the file system. So an EBS does not have to have a file system on it. Typically, if you're running it in JupyterLab, you have added a file system on top of it. But the difference between these services comes down to cost and networking speed. So EFS is typically less expensive but slower, and EBS is typically faster and more expensive. And so so as a user or as a small team of developers working on a project, you may wonder, do you need access to your own custom managed JupyterHub? Do you need to design your own, or work with people to design your own custom JupyterHub? Or can you just grab an account on an existing JupyterHub? And so that really just depends on your needs and what's available. So typically, if you just need one or a few accounts, and there are no and you have access to a particular hub, and that particular hub provides the resources that you require for your workflows, then you might as well just hop on an existing hub. However, different hubs have different access policies, so it's possible that not everybody on your team would have access. They provide different different amounts of resources, so they may not be able to run your workflows. So those are reasons why you may be pushed towards setting up a custom managed JupyterHub. This would be used to provide access to a large number of users. You control, as the owner of the JupyterHub, you control the access restrictions, and you also control what types of resources are added to the hub, and what server profiles are available. And if you require additional features and customizations, then you can usually work with a managed JupyterHub provider to develop those features with you or for you. So once again, if you're on someone else's managed JupyterHub, you just have an account on their service. The configuration is controlled by the owner. There are probably a variety of server configurations, but you really don't have much control over it. The cost varies. Some of these are free. Some are free, and you can purchase additional options on top of them. So some are based on credits, some are based on subscriptions. If you are setting up your own custom JupyterHub, then you are paying a managed JupyterHub provider, unless you're doing it all yourself, which is also a possibility. But in all likelihood, you're paying a managed JupyterHub provider to deploy this either to their own cloud account or to your AWS or your cloud account. But you define the configuration and you control user access. So this gets to a question of who owns, if you're working with a managed JupyterHub provider, who owns the JupyterHub? Is it you as the customer or the managed JupyterHub provider? So in terms of the cloud resources themselves, those are owned by the infrastructure itself is owned by the owner of the AWS account. So if it's deployed into your AWS account, then you are the owner of those resources. If it's deployed into a managed service provider's account, then they are the owner of those resources. However, most managed JupyterHubs are open source with very permissive licenses, allowing for commercial use, modification, distribution, and private use. So while they may own while whoever owns the AWS account owns the EC2 instances and the S3 buckets that are in it and in the Kubernetes cluster, the code that was used to set all of that up is open source. And so in pretty much every case that I've found, these are all open source projects, and you're able to take the code from your deployment, and you could take this and set up your own JupyterHub and manage it yourself. But the licenses are different for each of these services. So if you're curious about a particular JupyterHub or JupyterHub service provider, just take a look at their GitHub repositories and look at their licenses and see what they allow. But most of them are open source. So if the code is open source and free to take, then what is the benefit of having a managed JupyterHub provider? Why not just do it yourself? And so really the main value is not in a particular configuration of a JupyterHub or even the code that creates that JupyterHub. It's all of the knowledge that is required to plan, deploy, and maintain a JupyterHub. So when you're working with a JupyterHub provider, you typically are going to have meetings in which you discuss the needs of your users. So you'll decide whether you can get away with having a single server profile or whether you need multiple server profiles to handle the needs of different use cases. And it's important to determine those as accurately as you can, because anything that you purchase over the top, you're going to pay for. So you don't want to just pick the largest EC2 instance and assume that it's going to work for everybody. It's going to support every workflow because you'll pay a lot of money for that. So you want just the right size resource. So then the managed provider will also deploy the JupyterHub to a cloud platform for you. So if you don't have cloud engineering knowledge on your team, then that's handled by the service provider. The same is true with maintaining these systems. So there are regular updates that are required. If you let them go too long, AWS will start charging you more to manage older packages and older Kubernetes clusters. Things go wrong. Joe will talk about this tomorrow. Things often just go inexplicably wrong in the cloud, and You have to hop on and figure out what's broken and fix it. And so a lot of what you're paying for in a managed JupyterHub service is the expertise of setting up and running these into the future and maintaining them. So then there's also protection against accidental runaway costs. So if you're paying someone else to manage this for you, then you have a layer of protection over over those costs. If your JupyterHub service provider makes a mistake and that causes additional costs, you are protected from that. And so there's also the option for feature development. If you need something that's not included out of the box, then you can work with a service provider to develop additional features. And depending on the arrangements that you make with the service provider, there may be domain-specific user support. For example, in the case of ASF, we provide SAR support for JupyterHubs that are running SAR workflows. Oops. Okay, and so now just a quick review of some of the managed JupyterHub options out there. So these are not the service providers, but these are the actual JupyterHubs for which you could just start using or sign up for an account with if you are able, giving their access policies. So Binder is My Binder is a free JupyterHub that requires no authentication. So these can be launched from any GitHub repository. You can include a little Binder button on a GitHub repository that contains a Jupyter notebook and launch. And anybody visiting your repository can click that button and pretty quickly find themselves running running that notebook in JupyterLab. Resources are pretty limited, so they won't support large workflows. There's a short timeout period. I think it's about 10 minutes. There's no persistent storage, so if you walk away and your server times out, nothing that you've done is saved. And being a free service, it does sometimes get congested, and so there's not always a server available for you. Sometimes you go to run a binder and it attempts to run it 3 times and then tells you it was not able because there wasn't enough space. Then there's Google Colab. So Google Colab provides a free tier similar to Binder. You can just hop on and start running a notebook. But there's also the option to purchase additional credits. There is GPU access, I believe, even on the free tier. You can save directly to Google Drive, so there is persistent storage, and that way you can, of course, share your notebooks with Google or with GitHub. There are limited resources on the free tier, and then you can purchase additional resources. There are many open data sets hosted in Google Cloud. However, most NASA data is not hosted in AWS. If you're pulling a small amount, I mean, I've definitely worked in Colab notebooks where I'm pulling small amounts of NASA data, and I haven't had any problems moving them from US West to an AWS over to Google Cloud. But if you were trying to download lots and lots of data, I imagine that would become a problem. There's Open Science Studio. So this is another free and open JupyterHub. Excuse me. You do have to request access, but it doesn't have limitations on access, and it is meant to support multiple science domains. So this is hosted in the NASA Science Managed Cloud environment, the SMCE, and provides 10 gigabytes of persistent storage. There's also the MAP project. And so this serves the ecosystem community, and access is by invitation or request. And so this is, and persistent storage is also provided, I think, with S3. I don't remember off the top of my head. And so this is hosted by JPL and ESA. So there's a JPL hub and an ESA hosted hub. And so this is is meant to work with both NASA and ESA data. So depending on the whichever data set you're going to be working the most with, they tend to direct you to that hub so that you're adjacent to the data that you're going to be working the most with. Although either hub is capable of accessing data, from the other. They just try to position you for the most efficient data access based on what you're doing. And one interesting thing about MAP is that it also includes a data processing pipeline. There's CryoCloud. So this serves the cryosphere community. Access is upon request and is most often provided in conjunction with some type of an event, like a hack week or a workshop. They also provide persistent storage and have a library of cryosphere-related Jupyter notebooks. So this is hosted by the Colorado School of Mines, and this was deployed by 2I2C, which I'll talk about a little bit more at the end of the presentation here. So there's Leap Pangeo. And so I included Leap Pangeo on the list here, even though I doubt many people here can access it, just as a demonstration of the fact that many universities and organizations around the world are starting to set up and run their own JupyterHubs. And so this is one of these JupyterHubs. So this is hosted by Columbia University, and in Columbia runs a program called Learning the Earth with Artificial Intelligence and Physics, LEAP. And so this JupyterHub is open to all LEAP members. So you have to, presumably be affiliated with Columbia and LEAP in order to access this hub. It runs in Google Cloud and US Central 1, and this is also a 2I2C deployment. Then there's NASA OpenScapes, who we will be hearing from after this presentation and learn more about. And so NASA OpenScapes serves the NASA Earth Science community with the mission of helping people migrate to the cloud. So very pertinent to what we're discussing today. I just included this link to the OpenScapes Cloud Cookbook, which has a lot of really useful tools and data recipes and tutorials on how to migrate your workflows to the cloud. It's definitely worth checking out. And so access to the OpenScapes JupyterHub is also upon request and also typically in conjunction with some kind of an event. And so the hub offers persistent storage, and it's hosted by NASA OpenScapes and is also a 2I2C deployment. And finally, there's OpenSARLab, which of course you should all have access to now, because while it does serve, so this is a recent change. Up until March, I think, OpenSARLab was open to the public, to any user. However, we have had some restrictions put in place limiting access to NASA-affiliated users. But as members of the NISAR Early Adopters Program, everybody here is, by our definition, a NASA-affiliated user and has access to OpenSARLab, which will continue after this workshop into the future. So you will retain your access to OpenSARLab. So OpenSARLab provides 500 gigabytes of storage, which is deleted after 30 days of inactivity. And the reason why we provide so much storage is because this is run by the Alaska Satellite Facility DAC, and we are a sensor-specific DAC. So we provide SAR data, and of course, SAR data are very large, and so hence the need for a larger storage volume. So we provide server profiles and storage capable of running SAR workflows. We're hosted in, or we're running this in AWS in US West 2, so it's adjacent to large SAR data sets for quick data transfer. We provide a library of SAR-related Jupyter notebooks containing data recipes, and we provide user support both in terms of platform support for the JupyterHub, but also science support for SAR-related questions. And then just a quick, this is the last slide here, and so just a quick note of the current managed JupyterHub providers that I am aware of. And so it's a pretty short list at the moment. So there's 2i2c, and they're linked here. And so 2i2c will work with you to set up a custom JupyterHub deployment, and they have a number of different options for working with you, and the same is true with OpenSAR so you can go to the 2i2c website to find more information on their services, and if you're interested in learning more about a custom Open Science Lab deployment, then you can contact the Open Science Lab product owner here at ASF, Sergeant Shriver, who is also on the call here and gave the intro this morning. Yeah, and we can discuss options if you're interested in setting up a custom JupyterHub.